Today we're going to be talking about variability. All right, so we're going to start off with just a conceptual introduction to the different kinds of ways that you could measure variability. Then we're going to talk about range, quartiles, and interquartile range. Then we're going to talk about variance and standard deviation. And in particular, we're going to focus for a little bit on the concept of sum of squares. Then we're going to talk about population standard deviation versus sample standard deviation and talk about the differences in their formulas. And then we're going to calculate standard deviation in Excel. All right, let's get started. So let's think about a conceptual way of thinking about variability. There's lots of different ways that you could actually think about variability. So for instance, let me give you this example. Let's say this x right here, right? Let's say this x shown in each of these is the president. Right now, Barack Obama. And so let's say that this is the president. And these are different groups of people that are standing with him at some sort of formal party, right? Formal event. So here we see the Secret Service, and this is how far each of them are from him. Here we see the Supreme Court justices, and they're sort of scattered around him, spread out around him. Here are his cabinet members that he's appointed, and so they're sort of scattered around him. And here are the Tea Party senators. And let's just say maybe that there are senators that don't really like the president as much, right? And so they're sort of seem to be huddled over here, right? Now, which of these groups of people is sort of most spread out from the president, right? Which of these groups of people is sort of closest in, right? Who's closest to the president? Can we describe that with a number, right? Well, there's a couple of ways you might want to think about it. Well, one way might be, just look at the farthest person away from the president in each of these sets, right? So maybe for this, it's either this guy or this guy, right? And get that distance, and maybe that's the distance you need. So for this, maybe it's this guy, or maybe it's this guy, right? Maybe here it's that guy over there, right? Maybe here it's this guy, or maybe that guy. They seem pretty distant, right? Maybe that guy's a little bit farther, right? So just looking at the farthest person in the group, right? That's one way of looking at it. In that case, it doesn't really matter how many people in the group you have, right? So this group has fewer people than this group, but it wouldn't matter if we're just looking at just the one farthest guy in the group, right? That's one way of looking at it. Another way of looking at it is maybe creating a little boundary and saying, how many people are in that boundary, right? So maybe we have this little square around the president, and we just look at how many people are in that square. So maybe for here, if we draw, my square's sort of crappy, but if we draw a square like that, how many people fall in that square, right? If that was our measure, we would say, oh, this group is the closest to the president, right? Here we have like one person in the square, and none of the other groups have any people in the square, right? And then maybe we could look at different types of squares and see if that changes anything, right? So that might be one way of doing it. Another way of doing it might be to sort of maybe find the area of the border, right? Right? Maybe that's another way of doing it, right? Maybe this one. And that one doesn't seem like a very good model because that would mean that these people are the closest to the president. But this is sort of an odd group. They're close to each other, but not necessarily close to the president, right? Should that matter in a measure of variability? That's another thing to think about. But probably one that probably comes to your mind is sort of this idea of maybe the average distance of all these guys away from the president, right? So who has the closest sort of average distance, right? Then we also wouldn't need to worry about how many people are in the group because we divide by the number of people in the group, right? And it actually wouldn't matter if they're close to each other or not, right? We just care about distance sort of to the president, right? And so those are sort of different ways that you could think about variability. And so notice that they're all ways of sort of sticking a number on this concept of variability, but you might come up with different numbers, and you might come up with different sort of definitions for what it means to be spread out versus very close, right? So there are some things to think about. Should we be measuring how far they are from the center or how far they are from each other, right? So center is going to be an important concept in variability. So should we measure it from the median, the mode, the mean, right? Does it matter if this group has few or many members? Should that be taken into account? Does it matter what direction away from the president or from that center point, if it's to the right or to the left, up or down, right? And what about consistent clustering? Should that matter, right? So those are some things to think about when we think about a measure of variability. Now, there are lots of different kinds of measures of variability, and we're going to be talking about two sort of broad classes of them that are going to address these questions in sort of different ways. All right. So the first class of measures that we want to think about are range, quartiles, and interquartile range. This is sort of like the idea of just taking the one farthest guy or the one closest guy and looking at that person. And usually these measures of variability are used with median, right? It's usually about measuring spread around a median. So one of the reasons that this is going to be the case is that when we look at range, quartiles, and interquartile range, what we're really doing is taking a distribution and cutting it up, right? Either cutting it up in half, which would be the median, the middle point, or cutting it up into, let's say, quartiles, right? Which would be cutting it into fourths, right, instead of halves, right? All right, so that's sort of the idea, and that's why they're going to be using median as their measure of central tendency. So when we think about range, you actually don't need a central tendency at all. What you need is the minimum value and the maximum value and the distance in between. So you could sort of think of it as the maximum value in the set of x, right? And then subtract the minimum value in the set of x. Right? So if you had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 as your distribution, you take 10 minus 1, and your range is 9, right? The problem with that measure of central variability, even though it's really simple, very intuitive, it's highly susceptible to outliers. So if we changed our set to something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 100, right? All of a sudden, it would be 100 minus 1, and our range would be 99, right? And so just by changing one of our numbers, we could drastically change the range. Interquartile range is going to be less susceptible to those outliers. But before we get into how to calculate interquartile range, we have to learn how to divide that data into quartiles. So let's just look at a sort of simple example. Right? So here, what we would need to do is just divide this data into quartiles first. Since it's an even number, the median would fall in between 5.5, right? And then to divide it further into quartiles, we divide it at the 3, and divided at the 8, right? And so here's the first quartile, the second quartile, the third, the fourth. And because of that, these borders actually have special little names. These borders are called Q1, Q2, and Q3, just to indicate that they are the borders of the quartiles, right? And so first you divide the data into quartiles. And then basically, in order to get interquartile range, you're basically sort of lopping off these guys on the end, sort of like the end of bread or the end of cucumber, like we're just like sort of chopping it off and casting it aside, just in case that there are some extreme outliers, right? So here, what we do is then we take Q3 minus Q1, right? So in this case, it would be 8 minus 3, and the interquartile range would be 5, right? So here, the interquartile range sort of gives you the idea 50% of the numbers falls in this range, right? Because that's 2 quartiles, right? So that's 50% right there. And so that's why it's sort of a nice measure. It's more robust than actual range because it's less susceptible to outliers. It's still pretty intuitive, and it gives you that nice 50% of all the numbers falls in this range. All right, so that's interquartile range, pretty easy. So let's do an example, another example. So here, let's say there are these ages, right? And we want to know what the interquartile range of this is. Well, first it helps to separate them by quartiles. So there are 3, 6, 10 numbers here. So because of that, here's sort of the midpoint, right? So the median, also called Q2, that is 30, right? So that's the median. Here is Q1, and here is Q3, right? So Q1, Q3, right? And in order to find interquartile range, sometimes called IQR, it's Q3 minus Q1. So in this case, it would be 38 minus 20. So our interquartile range is 18, right? So within 18, so here we could just sort of draw that distance of 18. So in that distance, 50% of our numbers fall in there, right? So between 20 and 38. All right.